presentation is going to be revolving around this algorithm that we built using Python, and it's called ARI-CM, and that stands for Artificial Risk Index by Coding Minds. So basically, we built this for a competition, a global that's based in LA, and it was called the 2020 COVID-19 Challenge. And they were basically trying to find, using data sets and AI, to find some sort of way to benefit our local community in this time of COVID. So ARI-CM is mainly just a tool for interpreting data and helping schools reopen as safely as possible. So in case you guys haven't noticed, coronavirus is all over the news, and it's really affected how we live in our entire society, economically, politically, and especially in this case, we're going to focus on educationally. So basically, our education has been greatly impacted by how we teach and all these kind of things, and that all has to change because of the fact that we can no longer sustain a healthy environment when we're all clustered together in a dense population at school. So all these symptoms, sometimes can be rather flu-like, and it's often misdiagnosed. So then today we're just going to be focusing on how does COVID impact our education system.
So as many of you know, school has already started or will be starting soon. Regardless of this situation, schools still need to provide an adequate education system for students. However, going back to school is still very dangerous, as being in a crowded area is very unsafe, even with masks.
All right, so our goal. So we wanted to help schools have a way to reopen safely for all the students and teachers to find a way to stay safe. We want everyone to be aware of how COVID works and them to be well informed on what they can do to help prevent the spread.
So ARI-CM basically consists of two main Python functions, and these two, one of them calculates a risk index, which is kind of like how dangerous is it exactly, if you were to put on a scale, it is to go back to a certain high school based on high school's location, their racial demographics, the area case rate of the school, and even the square footage of the school. So then the second function would tell us how many masks do you need at the school. And this would be assuming some values like, if a person's wearing a mask, they only need to stay this far away from people. But if they're not wearing a mask, they need to stay a greater amount of distance away from people. And it would give you an exact number based on the school's approximate population of how many people at the school need to be wearing masks. So the most significant factors is how the density of the school's population and mask users correlate with the spread of the coronavirus. And again, this is what ARI-CM mainly is going to be looking at when it's data. Basically back to school reopenings through algebraic equations, and we're going to go over that more in detail later.
So below, we have graphs sampling the results of ARI-CM's calculations based on the percentage of students wearing masks, the x-axis, and its effect on the risk index, the y-axis. And overall, we do see a dramatic impact from the application of masks to school campuses. However, in some samples, it can be confirmed that the school's square footage is not sufficient in supporting its population of students and teachers, regardless of the usage of masks. And we will explain this in more detail in the demo and the code. So on the left, this is Grant High School, which has a noticeable decline of about 0.35 on the risk index, and this can be observed between around 25% and 50% mask usage.
All right, so this is how this is how the program is supposed to be implemented. So basically, we made a simple website where a user can select a school and then put in a percentage of people wearing masks. Then the program uses that data and it puts it for our algorithms to determine a risk index, and then gives out several pieces of information and graphs that the user can use. Let's say the user is a member of the school board. They can put in their school, they can put in a percentage of people wearing masks. And then the program will give them information that they can use to help make a plan for reopening school. And that would make it much safer for students and teachers.
So this slide is the main data that we use to write the algebraic functions that RCM is based off of. Basically, we found from several data sources that generally when people wear a mask, they're supposed to stay about 6 feet apart or more. And then when they don't have a mask, that extends to 13 feet or more. And then not safe is obviously, well, less than that. So this is mainly applying our code to help teachers best schedule what is the best way, or like percentage wise, how many kids should be in a school if your school is really small and you don't want the density to be super high. And this goes into the school's risk rating and also the amount of masks the school would need to combat however COVID's gonna drive it down.
So overall, our project was very challenging but worth it. And while we found the process of writing ARI-CM slightly stressful because of, number one, time constraints. So we had around 2 weeks to complete this project, but in reality, we really only used the last couple of days to write our code and start our research and all of that stuff. And number two, it was lack of relevant data sources. Our competition provided us with a lot of data, but none of it was really relevant to our topic, education. And three, we also had minimal experience with front-end coding, which kind of made it hard to make the website. However, ultimately, this rewarding experience allowed our team to further explore the capabilities of programming libraries. We really had fun working together, and we were able to experiment with a lot of new languages.
So in the future, ARI-CM is but a prototype with lots of potential to help a lot of people and hopefully reduce the amount of COVID cases in schools. And then in the future, we want to further improve on this prototype. We want to research and reevaluate new data sources, try to find more sources more relevant. We want to find a way to automate these data sources so that we don't have, it's much easier for this program to work. It will be much more efficient and won't require as much human interaction. We hope to incorporate more artificial intelligence models into our algorithms to help make our program more accurate, and then also put in more factors to also help the program become more accurate. And then we also hope maybe we might rename it to something catchier.
And a really big thank you to Dr. Sun and Daniel, because they both took out quite a bit of their time to help us sort out a bunch of stuff, even though they're both super busy. And we had a lot of questions about while writing this code. And I want to say minor, but they helped us figure out some really major bugs in our code. And we really wouldn't have gotten it done in time without those two. So thank you. We're not done yet, but thank you for listening to our presentation. So we're gonna show you guys a quick demo of the front end website before we go
Demo time.
So this is our introduction page. I'm not going to read it all because it's pretty long, but if you scroll down, we do have a demo video which we use to submit for our competition. And if you go back up, there is a bar with all of the different pages.
So this is our program. So first off, we have a drop-down menu with all the schools we have, which is not a lot. So yeah, pick a random one. All right, great, high school. Okay, so, and then we put in a percentage of the people wearing masks, let's say 45. So that's some information. We got stuff like the school name, the ages of people who go to that school, latitude and longitude, which is just basically location, total amount of people who is currently enrolled in that school, address, so we can see the general area of the people and see how many cases there are around that area, square area of the school to see how big the school is and how much space, like the student to area ratio, and then demographics. And then down there we have the recommended total amount of masks, risk index, and then a graph showing describing stuff. Yeah.
We're not going to read this because this is actually rather long, but we wrote it was just a quick, well, not quick, it's a report on ARI-CM about basically how the code is written, references, acknowledgements, and that's basically everything about the website. So now we're gonna show you guys the actual code behind it. So
Coding bits, yeah.
it's coded in REPL in Python language.
So in this beginning page, it's our main page where we import all of our stuff like Flask, which is used to connect our back end with our front end, and stuff like matplotlib, which is used to make our graphs. And if you scroll down a bit, we have our school list, which we
hard-coded right now, but hopefully we can automate that in the future. It'll be a lot easier for us, so we don't have to type in research that much.
And if you scroll down more, we have our function. The first one is called define calculate risk index, which is basically we use like the percentage of masks and some other factors to decide whether the risk index raises or not. And it goes through a lot of different calculations and like algebraic expressions to say whether it increases or not.
So then in the second function, it's called calculate mask. This one, it looks really complicated out here, but it's just pretty simple algebraic equation. So this first part is just taking the data from the dictionary up there with all the school information. It sets some variables that we're going to use, such as the total number of people at the school and then the square footage of the school. So then basically this equation is the amount of people that are wearing masks. They should be separated about 5 to 6 feet apart. So then that's about in every single direction. So then each person will occupy 5 by 5 square units approximately. And then the other people would, who aren't wearing masks, they need to have 10 to 13 feet apart optimally. And then all of that needs to equal the square feet. And also So then basically if the number of masks is number of people, if it calculates and it's less than 0, that means that the number of people, even if everyone wore a mask, is just too much for the school's area to accommodate. So then it prints out this message to the front end. Otherwise, it's just going to give the users actual value of how many masks they should be. This last part is just basically routing it back to the front end where the data is actually going to be displayed. This part's just HTML code for the front. And basically, this is coding for the header and then coding for all the other stuff, such as coloring, font size, which is over here in this.
So that's our CSS, and then that's all the styling things for our web page. Lots and lots. And then next we have JavaScript. So those are like scripts to automate stuff on the web page. And then you can, and then more scripts. And after that, we have the HTML for the other page.
All about the same.
Yeah.
Well, that's all we have to say about this for now. Anybody have any questions for us?
Yep, let's head into the Q&A time. If you have any questions, please type them in the chat, or if you can speak up, that'd be even better.
Probably not.
Not in its current state, I would say. Cause
we would probably have to improve it a lot before we consider publishing this website.
See, I think it definitely gets down to the main idea of what we're trying to do, but there's some other stuff I feel like because we built in such a rush 2 to 3 day span, there's some stuff we want to check over and maybe reevaluate some things before we were to publish it. So it's possible in the future, but not the current state that it's in.
Yeah.
Right, well then, what kind of improvements do you guys would want to add in the future?
Probably make the algorithms more complicated, incorporate AI models into it, make it more user-friendly, although I think it's already pretty user-friendly. And then, just add more schools, find a way to automate the way that we get our data sets.
Honestly, the way that RCM right now sorts the data is, I feel like there might be a better way we can do it. I want to try to find that better way. And also, perhaps instead of using like other types of classification or regression models to model this data, find a better fit for what we're looking at, and then just kind of make every part just a little bit more accurate, I want to say, to what's actually going on.
So what was the hardest thing there for your program to make a program?
So there's just one like entire day of time where our algorithm was messed up, I think, because we had some graphs with like 3 lines coming out of 1 line, and also a lot of flat lines. So we had to fix that, and Dr. Sun really helped us with that.
Yeah, we had surprisingly, we had a lot of issues with the graphs, and it just like combing through the code. Honestly, it was the minor bugs that really got us. And I guess it wasn't as difficult as it was time consuming, but building like customizing this front end was trying to find the different fonts and then that took a while too. It's just really time consuming for us. I've been doing Python code for probably, a few months, to be honest, not too long.
I've been coding for, I think, maybe around 2 to 3 years.
I've been coding for around a year, maybe a little longer.
I think someone has a question.
All right, I see a question.
Do you have any plan to rework on this project? Oh, that's Alyssa.
Maybe if we have a break during the school year, maybe like a weekend, we can chill a little bit and then maybe try messing around with the code a little bit, try getting it a little more accurate. I think if we do that a little bit every weekend, we can gradually make a really good program in a couple months.
Bob, how long did this project take? Okay, like Josh said earlier, it was for a competition that lasted about 2 weeks, but
we had school.
It was really sudden, and then we didn't really get to start until like the last 2 to 3 days of the project, and it was like we just basically worked on it the entire day over the weekend to get it done by, I think it was like a Monday or something. And so probably for the 3 of us, I want to say like over 10 hours for sure.
It's very impressive. So how was your competition experience? What is the competition? Like, how was that like?
So the general competition was help write a program that would help out the COVID-19 situation. It was purposely made extremely broad. They wanted to see what kind of programs people make. They had libraries of data sets that we could use, from stuff like car traffic data to maybe the amount of businesses in LA. There's a lot of data sets. We decided to focus on school because we're all students, and I feel like we could represent the learning system the best.
I think it was I kind of forget the name of the exact name of the organization, but they provided tons of resources. They had multiple coaching sessions for people, and they had like Zooms where you could talk to actual professors and stuff. They gave us quite a few resources, just like lists and even different mentors you could talk to about everything. So I think in general, not a bad first experience at all.
Yeah, it was really fun.
So who actually came up with this idea? Like, did all of you guys agree or you know?
So when they did bring the project up, we had a brainstorming session where me, Mae, and Josh all threw ideas, and then Dr. Sun was like giving us advice. And then I think it was Dr. Sun who came up with this idea.
Yeah, just like we were from the beginning, you were just like this idea, like let's do something with masks, and then Dr. Sung was recommended us to do something that really involved us personally, since as students, and it wasn't really a competition geared towards him specifically. It was more towards more experienced coders. So he recommended we did something in our community. So obviously we all are students, so we decided to go something in the education system, and that's kind of where it all sprang up from.
And yeah, to add on to May, the competition was basically all adults or like at least college level people. So that's why Dr. Sun said that it would probably be best if we choose a topic that maybe some other people wouldn't really know about.
Okay.
Oh, do you guys remember like the specific bugs that you guys had to overcome?
I think the first one that comes to mind is the graphs. We reformatted the graph so many times. It was just like we had 3 data inputs going into the graph, but somehow ended up with 4 lines, and we were all so confused. It was like this one graph that was like sine wave function going on. So I think that it ended up being some kind of bug with how we were coding the like how just in general how we were putting everything, all the data into the matplotlib. That's the first one that comes to mind.
And we also had some trouble formatting our website.
Oh,
Like,
yeah, that was a pain.
yeah,
There was
there was a white line, a white bar in between the search bar and the green, and we spent like 3 hours trying to fix that, and it took us like quite some time to look that up.
like changing every single value I could find in an attempt to get rid of that bug. And then after a while, we finally decided, okay, you know what? We can't do this. Let's ask Dr. Sun. So we went on WeChat. We said, hey, Dr. Sun, can you help us debug this website really quick? And he popped on, and then he fixed it in 2 minutes.
Anything you want to say?
Guys did a good job.
Thank you.
Thank you.
Happy to hear that.
I guess all we can say is just stay safe.
Yeah, stay safe.
Wear a mask. I think.
Please wear a mask.
A huge
We did lots of research. Masks help
Yes.
a lot.
Yeah. Just don't spread your whatever. Lots of people are asymptomatic. Just wear a mask. I think if there's one thing that's program proved is that masks do matter, and they do affect the overall range. So
Make sure to follow us on Twitter at Coding Minds Academy. No, at Coding_Minds, and then follow us on Facebook at Coding Minds Academy.
Yeah, so yeah, that's it for tonight's Coding Minds project presentation. Great job, Mae, Colin, and Joshua. Tune in next week for another Coding Minds conference, and we'll see you then. We want to thank you on behalf of Coding Minds, and have a great evening, everyone. Thank you. You guys are
Thanks for coming.
Guys, good job.